Good evening to everyone. Today's class we discuss about the linear Diophantine equation. Okay, first we should know about Diophantine equation. Diophantine equations contains is an equation contains only integer solutions. Contains only integer solutions. What is the difference between the previous normal equation and Diophantine equation? Say example, I can consider x plus y equal to 2 and x minus y equal to 0 is the equation. So what is the solution for the x and y? The x and y are solutions of 1. We can consider this equation as 1. Okay. Now we can consider another one equation. X plus y equal to 1 and x minus y equal to 0. Now, what is the solution for the second equation? The second equation solutions are x equal to 1 by 2 and y equal to 1 by 2. Now, see this. What is the difference between these solution and these solutions? Both are solutions for the given equation, but what is the difference between them? The difference is in the solutions. See this, x equal to 1, y equal to 1 are integers in number, integers. But x equal to 1 by 2 and y equal to 1 by 2 are the real numbers. That's a difference we can assign the solutions. So the linear Diophantine equation means it contains only Diophantine equations contains only integer solutions. Only integer solutions. Okay. Now, every equation having some advantages. What is the advantage of or applications of the Diophantine equations? The applications are 1. Cryptography. For security purpose, we are using the Diophantine equations. Used. Second one, finance and commerce. Currency conversions. We can use Diophantine equations. Third one, communication systems. Error decoding. We can use Diophantine equation. Fourth one, in operation research, for transportation problems, and optimizations, we can use the Diophantine equations. Now, we can come to the linear Diophantine. What is linear Diophantine? An equation in the form of ax plus by equal to c is called linear Diophantine curve. Diophantine equations. Okay. Now, for solving linear Diophantine equations, we have some steps. So, what is the step? One, first step, working rule for solving Diophantine equations. Oh, one, first we got to identify the elements A, B, and C. Second one, we want to find the GCD of A and B. Third one, suppose the GCD of A and B are C. We assign like that. So D, we can assign D. Then the D must divide C. Fourth step, we can assign some initial solution for X and Y. That is taken as X naught and Y naught. Now, the solutions are X is equal to X naught plus B by D into T, and Y equal to Y naught minus A by D into T. These are the solutions for the problem. Okay. In this concept, we discuss about two things. First, we discuss about GCD. And we discuss about divides, divisibility. Okay. First, we should understand the concept of divisibility and GCD. What is divisibility? Suppose a number A and B be the two numbers, we can say A divides B. A divides B means B should return as some A into C. Means B divided by A, that is B divided by A, B divided by A, which gives the remainder 0. Remainder 0. Means we can assign in simple manner, we can assign like that. Say example, 3 divides 9. 3 divides 9. We can return this 9 as some 3 into 3 plus 0. So 3 multiplied with 3 is equal to 0. So we can say that 3 divides 9. Divide 9. Similar manner, we can say 2 does not divide 5. Why? Because 5 can be written as 2 into 2 plus 1. So here we get the remainder 1. By the divisibility concept, the remainder must be 0. Not equal to 0. Therefore, we can say 2 does not divide 5. That is we represented by 2 does not divided by 5 in this way. Now, we can come to the next definition. What is the definition? GCD. What is GCD? Everyone knows about the GCD. What is GCD? The greatest common divisor. Okay. So what is the greatest common divisor? Suppose A and B are two numbers. A number, say D, is the largest number, which divides both A and B. Both A and B. Here, D is called the GCD of A and B. That is, we can denote as D is equal to open brace of A comma B. Normally, we denote D. GCD is denoted by open brace of A and B. Now, we can say, take an example, 12 and 18. We know that the factors of 12 are 1, 2, 3, 4, 6. That's it. For 18, 1, 2, 3, 6, 9. So what is it? The common numbers which are divided by 12 and 18 are, what is it? 1, 2, 3, and 6. Which one is the largest? The largest is 6. Therefore, the GCD of 12, 18 is 6. This is the way we have to calculate the GCD. But it is very easy when solving simple problems. Suppose if a digit contains more than, if a number contains more than 2 digits or 3-digit numbers, it is very difficult to find the GCD of the problem. For solving this GCD, we are using two concepts. One, canonical decomposition. Canonical decomposition. Second one, Euclidean algorithm. Okay. So now we will see the Euclidean algorithm, how to find the GC. Say example, we can choose 12 and 8. We can choose the same example, 12 and 8. So 12 and 8. So what is it? Euclidean algorithm states that suppose A and B be the two numbers, then we divide B by A, which has some quotient plus one remainder, say R. This R must be less than or equal to 0 and less than A. Now, next step, we can divide this A by R, which gives one quotient, say Q1 plus one remainder R1. So the R1 lies between 0 and A. So R. Similar manner, we can proceed. We can say we can get Rn is equal to Qn into R power n minus 1 plus R power n plus 1. The next step we can move. Say example R n plus 1 n plus 2. Now I divide R plus n plus 1 divided by R power n plus 2 with the quotient Qn plus 1 plus the remainder 0. Then we can see the last non-zero remainder is called GCD. Means in this column R power n plus 2 is the GCD of the n of A and B. Now we can apply the same concept in the problem 12 and 18. Suppose we consider the A equal to 12 and B equal to 18. Now I divide 18 by 12. So what is the quotient? The quotient is 1 plus the remainder is 6. Next, this 12 is divided by 6. So what is the quotient here? 2 plus the remainder 0. So we reach the final step. Now we can go to the last non-zero remainder. So 6 is the last non-zero remainder. So we can say that the GCD of 12, 18 is equal to 6. This is the way we got to find the GCD of any numbers. Okay. So I hope you can understand how to find the GCD of the problem. Because finding GCD is very, very helpful, especially in solving the linear Diophantine equations. Now, come to the first problem. Suppose we can consider one equation. 6x plus 8y equal to 5. First, we want to check it is a solvable or not. Is solvable or not. How will we verify then? First, we got to find, we want to check it is solvable or not. How to check then? How to check it is solvable? First step, we want to find the GCD of 6, 8. The GCD must divide 5. We can say it is solvable. Now, what is the GCD of 6, 8? 6, 8 is 2. Clearly, we understand. Say example, 8 can be written as 1 times of 6 plus 2. 6 can be written as 3 into 2 plus 0. So from the statement, we can understand the GCD is 2. So now, the 2 must divide 5. You can see then 5 can be written as 2 into 2 plus 1. I already mentioned that for the divisibility condition, the remainder must be 0. Here the remainder is 1. So from that we can understand that 2 does not divide by 5. So therefore it is not solvable. Means we cannot find any solution for the problem. It has no solution. Okay. Now we can come to the second concept. Say example, another one example we can consider. Solve 12x plus 18y equal to 30. Now, What is A in this problem? A is 12 and B is 18. Okay. What is the GCD of 12 and 18? That is open brace of 12, 18 is equal to 6. Now clearly we understand that 6 is a number divided by 30 because 30 can be written as 5 times of 6 plus 0. So the remainder is the remainder is 0. So it is divisible. So definitely 6 divided by 30 means it is solvable. It is solvable and it has solution. Oh, this is the first way you got to identify the equation contains solution or not. Now we can go to the problem 1 for solving the solution. So in this previous problem, we check only solvable or not. Now we can take this problem and we can solve, and what are the solutions we have for the problem? 1. Solve the linear Diophantine equation, LDE. LDE denotes the linear Diophantine equation, 12x plus 18y equal to 30. What are the steps I mentioned in the previous procedure? 1. First step, identifying ABC. I repeat the steps. Identify ABC. Second one, find a GCD of A comma B, say D. Third one, D divided by C. Divide C means we can get solvable and we can get solution. Fourth step, we can assign the initial solution x naught and y naught, which is solved x naught and y naught. Second one, the solutions are x is equal to x naught plus b by d into t and y equal to y naught y equal to y naught minus a by d into t. Okay. Now, by the procedures, we can identify, we know that the general form of the equation, general form is ax plus by equal to c. Comparing 12x plus 18y equal to 13, we understand that a equal to 12 and b equal to 18 and the c value is 30. Now, the GCD of 12, 18 already we found this number is 6 and 6 is divided by 30. Therefore, it is solved. So we have solution for the above problem. Now, what is the solution for the problem? We know that what is the initial solution? We can assign x naught equal to 1 and y naught equal to 1 for this problem. Say example, 12 times of 1 plus 18 times of 1 equal to 30. It satisfies. So this is the exact solution. When initial solution for the problem. Now, x can be written as x naught plus b by d into t. That is, what is x naught? 1 plus, what is b? B is 18 divided by d is 6 times of t. That is 1 plus 3. And what is y? Y is y naught minus a by d into t. That is, what is y? Y is 1 minus of a is 12 by 6 times of t. That is 1 minus 2. 1 minus 2. Now we have some solutions. What is that? X equal to 1 plus 3t and y equal to 1 minus 2t. Means it has infinite solution. It has infinite solution. How will I mention that it's infinite solution? Because when t equal to 0, we can get x value is 1 and y value is 1. Definitely 12x plus 18y satisfy this equation. For the x value 1 and y value 1. Suppose t is negative, we can consider as a minus 1. So what is the x value? X value is minus 2 and y value is plus. Check with that 12 times of 3 plus 18 times of y. So 12 times of minus 2, 18 times of 3. What is your answer? 12 times of 2 is minus 24 plus 18 times of 3 is 54. Definitely the answer is 30. It's solved. Means x equal to minus 2 and y equal to 3 satisfy this problem. Suppose we can assign t equal to 2. We get what is the x value? X value is 7, y value is minus 3. Now 4 minus 3. So what is the x value? So 12 times of 7. 12 times of 7 is 84 plus 18 times of minus 3. So what is your answer? 84 minus 54. The answer is 30. So this is the reason we can say it has infinite solution. Based upon the t values, we can get different x values and y values. So we can say that it has infinite solutions. I hope you can understand for solving this linear Diophantine equation. So the solution for the above problem is x equal to 1 plus 3t and y equal to 1 minus 2t. Now we can choose another problem. Solve (71x minus 50y equal to 1). Okay. We are seeing that it is very difficult one. Okay. Now we can come to this problem. Here, what is the a value? 71. B value is 15 minus 15. We can consider the negative positive integers only. The GCD is, we can consider as 71 comma 15. 71 is the prime number and 50 is a composite number. The GCD of a prime number and a composite number is always 1. So we can understand that the GCD of 71 comma 50 is 1. Also the D divides C. That is 1 divides 1. It is always solvable. We can understand that. So it means it is solvable. And we have solution. Now only the first issue we are facing that. What is that? Finding the initial solution. How to find the initial solution? That is a very difficult for solving this type of problems, because some problems we can assign x value and y value, we can easily get the answer. But in this problem, it is very difficult to identify the number. So what is the way? For that, we are using the Euclidean algorithm. Okay, what is the Euclidean algorithm mentioned then? Suppose 71 and 50 is the two numbers. I divided this 71 by 50. So what is your answer? 1 times of 50 plus 21 is a number. Now 50 can be written as 21 be divided by 21. So 2 times of 21 is 42. So balance is 8. Okay. Now 21 is divided by 8. So how many times? 2 times of 8 is 16. So the balance is 5. Now 8 can be divided by 5. So how many times? 1 times of 5 is 5. What is the balance? 3. Now 5 can be written as 1 times of 3 plus 2. Now 1 times 3 can be written as 1 times of 2 plus 1. The last one, what is it? 2 can be written as divided by 1, means 1 times of 2 plus 0. From that, we can understand the GCD is 1. That is 71, 50 is 1. We understand that. That is, I already mentioned that. Now, our aim is to find the initial approximate solution. Okay, how to find the things. Now, we can come to the previous steps. We can return this. Already everyone knows that one theorem is in GCD. Suppose A and B have the GCD D. We can return D as the linear combination of A and B, which is an important theorem we discuss in the, means everyone discuss in the GCD. Now, we are using the theorem to find the initial approximation solution. Say example, in this problem, we understand that one is a GCD. So now we can return this one as 3 times of 1 minus 1 times of 2. So I wrote this term from this equation. Okay, so 3 minus of 1 of 2. Now I want to write this 3 and 2 must replace by this 71 and 50. From that we can easily understand that. Now this 3 can be written as, so first we written 2. So 3 minus of 1 times of, how will you write that? 5 times of minus 3. This minus we can apply then. So from that we can get, this is 2 times of 3 minus 1 times of 5. Now the equation converted into in terms of 3 and 5. Now we can once again replace that. This can be written as 2 times of 8 minus of 1 times of 5 minus 1 times of 5. That is 2 times of 8 minus 2 minus 1. So 3 times of 5. Now we can come to the next step. So 2 times of 8 minus 3 times of 5. 5 can be written as what is it? 21 minus of 2 times of 5. This can be written as 2 times of 8. 21 minus 2 times of 8. 3 times of 21 plus 6 times of 8. This can be written as 8 times of 8 minus 3 times of 21. Now we return this 8 as, like the previous step, we can see then, now 8 can be written as 50 minus 2 times of 20. So 8 times of 50 minus 2 times of 21 minus 3 times of 20. That is 8 times of 15 minus 16 times of 21 minus 3 times of 20. Now, this can be written as, minus 19 times of 21 minus 80 times of 50. Now, 21 can be written as, by the previous step, 71 minus of 1 times of 50. So, this can be written as minus 19 times of 71 minus of 1 times of 50 minus of 8 times of 50. That is minus 19 times of 71 plus 19 times of 15 minus 8 times of is a plus 1. Here plus 8 times of 50. So therefore I got 27 times of 15 minus 19 times of something. Already we know that the given equation is 71y, 71x minus 50y equal to 1. Means in the place we can return this above equation, we can return this one statement as 1 equal to 71 times of minus 19 plus 50 times of minus 50 times of minus 27. Because 50 contains negative. That's the reason. Now we can compare these two equations. We can get what is your answer? X naught is 19 and Y naught is minus 27. This is the initial value for the given problem. Now we can come to the final solution for the problem. So what is it? X is equal to X naught plus B by D into T. So what is the answer? X naught is 19. Sorry, minus 19. So minus 19 plus B value. B value is what is it? Minus 50 divided by T value is 1 into T. So the answer is minus 19 minus 50 into T. Similarly, Y equal to Y naught plus A by D into T, which means Y naught. What is the Y naught value? Minus 27 plus, minus, this is a minus of A. What is the A value? Minus 70 plus 71 divided by 1 times of T. So what is your answer? Minus 27 minus 71 times of T. Therefore, we can get the solutions of X equal to minus 19 minus 50t, and y values are minus 27, minus 71t. Now we can see another one problem in this category. Third one, the same model. I can explain another one problem for this concept. Solve 93x minus 81y 3. Now come to this problem. What is the A value? A value is 93. B value is minus 81. C value is 3. What is the GCD? GCD is A comma B. We can omit the negative sign. So what is your answer? 93 comma 81. 81. What is the GCD? We can use Euclidean algorithm for finding the number. 93 can be written as 1 times of 81 plus 12. So 81 can be written as 12. 5 times of 12 or 60. 6 times of 12 are 72. So 6 is the only possibility. So the balance is 9. So 12 can be written as how many times of 9? So 1 times of 9 plus 3. Now 9 can be written as 3 times of 3 plus 0. Already we know that by Euclidean algorithm, GCD is 3 because the last non-zero element is 3 in this problem. Okay. Now we understand what is it? The GCD for the given problem. Our aim is to find the initial solution. Like the previous problem, the equations A and B are 93 and minus 81, which is very difficult to find the initial solution for this problem. So once again, we return this number as a linear combination. GCD as a linear combination of 93 and 81. We can identify the initial solution for the given problem. Now, what is the GCD? The GCD for this problem is 3. Now, this 3 can be written as 12 minus 1 times of 9. This is the first step. Now, this 12 can be written as, what is the way? 81 minus of 81 minus of 6 times of 12. So we can return this 12. We can keep it 12 as a 12 minus 1 times of this 81 can 9 can be written as 81 times of minus 6 times of 12. So the equation becomes 181. So 12 plus 6 times of 12 minus 1 times of 81. That is 7 times of 12 minus 1 times of 81. Okay. So the next step is 7 times of 12 minus 1 times of 81. We return this as linear combination of 93 and 81. So this 7 times of 93 minus of 81 minus 1 times of 81. This can be written as 7 times of 93 minus 7 times of 81 minus 1 times of 81. This can be written as 7 times of 93 minus 8 times of 81. 8 times of 81. From that we can understand that the initial solutions are, we know that the solution equations are 93x minus 81y equal to 3. Comparing these equations, comparing the equations, we can assign x naught equal to 7 and y naught equal to 8. We can understand that. Therefore, the solution x is equal to x naught plus b by d into t. That is x naught is 7. What is the b value? B value is minus 81 divided by d is 3 times of t. So the answer becomes 7 minus 81 divided by 3 is 27 times of t. Similarly, y equal to y naught minus of a by d into t. This can be written as y is 8 plus minus of a is 93 by 3 times of t. That is 8 minus 93 divided by 3 is 31 t. Therefore, the solutions are for the problem is x is equal to 7 minus 2017 and y equal to 8 minus of 31. Now, as of now, we discuss about the equation which contains two variables. Suppose if the equation contains three variables, how will you solve that? That's a step. So first step, we can reduce, say example, and we can consider another problem. 4, solve the LDE, 6x plus 4y plus 8z equal to 10. It's a standard question. We understand that equation contains three variables, x, y, and z. But we have the problem, we have the solution for either x and the variable contains x and y. But here, the third variable z is also available. So what is the procedure? First, we want to convert this problem in terms of two equations. We want to solve the problem. After that, we can go to the third variable. Okay. Now consider the given equation 6x plus 4y plus 8z equal to 10. We can assign some numbers, some variables. A dash is 6, B dash 4, and C dash is 8, and F dash I can assign as 10. Because D we are using for the GCD. So, and also ABC is a little confused. So that's the reason I'm using A dash, B dash, and C dash, and F dash. Now, first we got to verify the problem is solvable or not. Now, we want to find the GCD. Say example, D dash we can consider. So what is GCD of A dash, B dash, and C dash? So what is the answer? 6, 4, 8. The answer is 2. We understand that because 6 and 4 are 8 are the multiples of 2. Therefore, the equation, the GCD of the given problem is 2. And this 2 divides 10. So, the equation is solvable. We can find solution for the problem. We can clear that, we can find the solution for the problem. Now, our next step is They reduce the problem into two variables. Reduce to two variables. How to solve it? First, we understand then the 4y plus 8z. We can consider the equation 4y plus 8z. Clearly, the GCD of 4, 8 is 4. So, we can assign 4y plus 8z equal to 4u. This is taken as the first equation. This is taken as the first equation. Now, the equation 6x plus 4y plus 8z can be written as 6x plus 4u equal to 10. This is considered as equation 2. Now, we want to find the solution for the x value and u value, a new variable u, instead of y and z. Now, we want to check once again the equation satisfy the solvable condition or not. So, in this problem, we can consider a equal to 6 and b equal to 4, c equal to 10, because it contains two variables. So, we can use the previous notation ABC. Here, what is the d value? D is a comma b, which is nothing but 4 comma 6. The answer is 2. Definitely, the d divides 10, so it is solvable. Now, we can come to the solution. So, what is the initial solution for this problem? Because it's a very easy one, we can easily say then, what is the initial solution? X naught is 1 and u naught is 1, because the variable here 1, u naught. So, we can assign as x naught 1 and u naught is 1. Therefore, the solution is x is equal to x naught plus, from this problem, the answer is d by d into t. So, what is the answer? 1 plus, what is the b? B is 4 divided by d is 2 into t. So, the answer is 1 plus 2t. And the y values are y naught minus of a by d into t. That is 1 minus of a 6 times of 2 into t. That is 1 minus of 3t. So, this is the u variable u. Because u is the only variable we are using that. Therefore, we can get one solution x. What is x? 1 minus 2t, 1 plus 2t, and u is 1 minus 3t. But we need the solution for y and z, which is missing here. Now, we can come to the problem. So, already we consider 8y plus 4z equal to, we can consider 4y, what is the equation we can consider? What is the given equation? 8y, 4y plus 8z. We can consider the 4y plus 8z equal to 4e. Now, we can consider this equation as 4 equal to, we return this 4, the GCD 4, as a linear combination of 4 and 8. As a linear combination of 4 and 8. How will you write then? 1 times of 8 minus 1 times of 4. A simple manner. So, we can clearly understand that this 4 can be written as 1 times of 8 minus 1 times of 4. So, what is the difference between these two equations? The left hand side contains, means the equation contains 4u, but here only 4 is available. So, we can multiply u on both equations, u on both terms. So, what happened? 8 times of u minus 4 times of u equal to 4u. Okay. But what is u in this column? U is 1 minus 3t. We know that u value is, what is it? 1 minus 3t. Therefore, the equation becomes 8 times of 1 minus 3t minus 4 times of 1 minus 3t equal to 4 times of u. That is 4 times of 1 minus 3. Now, compare this equation and this equation. We can get the initial solution. See this. In the place of y, minus of 1 minus 3t is present. Comparing these two equations, in the place of y, we can get minus of 1 minus 3. Otherwise, we can return here 8z plus, I can return here 4y equal to 3. Now compare the values. The y value is, what is it? Minus of 1 minus 3t. And what is the z value? Z value is 1 minus 3t, which is our initial solution. I can assign this as y naught equal to minus of 1 minus 3t and z equal to 1 minus 3t. Is z naught the initial solutions? Okay. Now, our aim is to find the y value. What is the y value? Y value is on y naught plus b by d into t. Here, the b value is, we can assign as b is, what is it? We can consider the equation 4y plus 8z equation. So from the statement, what is the b value? B value is 8. And what is the a value? 4. And GCD of 4, 8 is, what is it? 4. So therefore, I written this as y naught minus of 1 minus 3t minus of plus b value 8 times of 4 into t dash I am using, because already I am using the variable t. So for differentiating the variable t, I am using t dash. So therefore, I got the solution. What is the solution I got? Minus of 1 minus 3t plus 2 times of t dash. So this is the answer for y. So what is z value? Z value is z naught minus of a by d into t. What is the z naught value? 1 minus 3t. And what is the a value? A value is 4 divided by 4 times of t dash, t dash. That is 1 minus 3t minus of t dash. Therefore, I got two equations. I got the three solutions. What is the solution? X is equal to 1 plus 2t and y values are 1, y values are minus 1 minus of 1 minus 3t plus 2t dash, which is nothing but minus 1 plus 3t plus 2t dash, and z values are 1 minus 3t minus tt dash. Okay. Now, we want to check the equations are correct or not. At the time only we can confirmation the equation. So what is the equation I have? 6x plus 4y plus 8z equal to 10. Now I want to verify these solutions are correct one or not. How to verify this? Take t equal to 0 and t dash equal to 0. I am saying t equal to 0 and t dash equal to 0. What is the x value I got? X value is 1, y value is minus 1, z value is 1. Check the answer. 6 minus 4 plus 8. The answer is 10. It's correct. Suppose we can assign t equal to 0 and t dash equal to 1. What is the x value? X value is, what is the answer? T value is 0. So x value is 1. Y value is 1 minus 3t. Minus 1 plus 3t. So minus 1 plus 3 times of t. T is 0 plus 2 times of t dash is 1. So the answer is plus 1. Next, z value is z value is 1 minus 3t minus yt dash, which is nothing but 1 minus 3 times of t. T is, what is the value? 0 plus t dash 1. The value becomes 0. Therefore, I got x equal to 1 and y equal to 1 and z value is 0. We can check the answer. The answer becomes 6 plus 4 times of 8 times of 0 equal to 10. So it's satisfied. From that, we can understand that the equation satisfies the problem. Okay. We can understand that these equations x equal to 1 plus 2t and y equal to minus of 1 minus 3t plus 2t dash and z equal to 1 minus 3t minus t dash satisfies the problem 6x plus 4y plus 8z equal to 10. For understanding purpose, we can see another one problem in this same model. Take another one problem, solve that LDE 2x plus 2y plus 3z equal to 5. Okay. Now we can consider a equal to 2, a dash. As like the previous model, a dash equal to 2 and b dash equal to 2. C dash equal to 3. Now, what is the G dash? D dash is the GCD of A dash, comma B dash, comma C dash. So what is your answer? 2, 3, which is equal to 1. Because 2 is a prime number, 3 is a prime number, so the answer must be 1. Now, we can reduce the problem 3 variables to 2 variables. Okay. How will you reduce that? We can consider 2y plus 3z. What is the GCD of 2y plus 3z? 2 is a prime number and 3 is a prime number. So the GCD is always 1. So 1 in t. So we can assign 2y plus 3z equal to. Now the equation 2x plus 2y plus 3z equal to 5 changes into 2x plus u equal to 5. Now, for solving the two variables, x and u, we find the initial solution. X not equal to 2 and u not equal to 1. It definitely satisfies. 2 times of 2 plus 1 equal to 5. Satisfy this problem. Now we can find the solution. X is equal to x naught plus b. What is the b value? B value is 1 b by d into t. That is x naught 2 plus b value is 1 divided by d is 1 times of t. So the answer is 2 plus t. Now, for u, we use the formula u minus u naught minus a by d into t. That is, what is the u naught value? 1 minus of a. What is the a value? 2 divided by 1 times of t. That is 1 minus 2t. 1 minus 2t. Therefore, we can get the solution x is equal to 2 plus t and u equal to 1 minus 2t. 1 minus 2t. This is the solution for the problem for x and u. But we need the answer in terms of y and z. Now we can come to the given equation. Already we assigned one equation. What is the equation we assigned? 2y plus 3z equal to u. Okay. So, what is the GCD of 2, 3? The GCD of 2, 3 is 1. That is already we find. So, this 1 can be written as the linear combination of 2 and 3. How will you write then? 1 times of 3 minus 1 times of 2. This is the way we got to write the linear combination. So 1 can be written as 1 minus 3, 1 into 3 minus 1 times of 2. Now multiply u on the equation. So u can be written as 3 times of u minus 2 times of u. Okay. But what is the u value? U value is 1 minus 2t. We can assign that. That is 3 times of 1 minus 2t minus 2 times of 1 minus 2t. Now, we can assign the initial solution by comparing these two equations. By comparing these two equations. What is your answer? We can return this as 1 minus 2t equal to 2y plus 3z. So 3z plus 2y. In the same manner, we can return. From that, we can understand the initial solution y equal to minus of 1 minus 2t and z, the initial solution z naught equal to 1 minus 2t. Now, we can come to the solution, final solution. What is the solution? Y equal to y naught plus b by d into t. What is the b in this column? B is a variable. B, we can find the b from the equation 2y plus 3z. We can find the b from this equation 2y plus 3z. So from the above, we can understand a value is 2 and b value is 3, definitely. Okay, therefore a value is minus of 1 minus 2t plus b value is 3 divided by 1 into variable we can assign as t dash. That is minus of 1 minus 2t plus 3 times of t dash. This is the answer for y. Next, we can find the x value, z value. What is Z value? Z is equal to Z naught minus of A by D into T dash. That is Z value is Z naught value is 1 minus 2T minus of A. A is 2 by 1. T dash is 1 into T dash. That answer is 1 minus 2T minus 2T dash. Therefore, we get one solution. X is equal to 1. X is equal to 1 plus 2 plus T and y equal to minus 1 plus 2T plus 3T dash and Z equal to 1 minus 2T minus 2T dash. Is the solution for the problem. Now we want to verify this answer by taking T equal to 0 and T dash equal to 0. So what is the X value? X value is 1, X value is 2, and Y value is minus 1, Z value is 1. The equation is 2x, so 2 times of 2 plus 2y, 2 times of 1 plus 3 times of z. Z is 1. So answer is 4 minus 2 plus 3. The answer is 5. It satisfies. Therefore, we can assign that. Similar manner, we can assign t equal to 0 and t dash equal to 1 or t equal to 1, t dash equal to 0. Like different assigning different numbers, we can find the value of the x value, y value, and z value, which satisfy our given problem. Therefore, it contains infinitely many solutions for the given problem. Thank you, students. I hope you can understand the problem of linear Diophantine with 2 variables and 3 variables. Thank you. We will see you next session. Thank you.